Hello girls, I hope you're staying safe at home. To continue with the chapter Atomic Structure and Chemical Bonding, today we are going to learn about the electrovalent bond, which is also known as the ionic bond. Now in the last upload, I told you that the chemical activity of any atom depends upon the number of electrons in the outermost orbit, because all atoms which have less than 8 electrons, they tend to attain the octet configuration so that they can become stable. So if any atom has less than 8, that is from 1 to 7 electrons, they show chemical activity. They will want to react with another atom so that their outermost orbit will have 8 electrons. So atoms of metallic elements, remember children, have 1, 2 or 3 valence electrons. That means electrons in the outermost orbit. So they can easily lose 1, 2 and 3 electrons to atoms of non-metallic elements. Remember children, non-metallic elements have 5, 6 or 7 electrons. Okay, so they have that many electrons in the outermost shell and therefore they form an electrovalent compound. So if we take a look, if 1 electron is given to the atom which has 7, total number will be 7. When this is lost from the outermost orbit, the second last orbit will have 8 electrons, isn't it? So they attain octet configuration. Similarly, 6 plus 2, 8, 5 plus 3, 8. Okay, so after there is the transfer of electrons, remember children, the number of protons, the positive charge, is equal to the number of electrons, that is the negative charge. So if say any atom has 10 protons is equal to 10 electrons, so this will be cancelled and the atom is electrically neutral. It does not have any charge. But if this atom, supposing 10 electrons it has, which is equal to 10 electrons. Now if this atom loses one electron it loses, so now it will have 9 electrons. So which charge is more? So it is not equal to 10 protons. This atom is not losing protons, it is losing electrons. So now you see it has more positive charge. So this atom is going to become a positively charged ion. Okay, similarly, when this is losing 1 electron, another atom is gaining 1 electron. Say supposing the other atom has say 11, which is equal to 11 electrons. Now it is receiving 1 electron. That means now how many electrons does it have? 12 electrons. Okay, so is it equal to 11 protons? No, it is not equal. So that means now you see which charge will this atom now gain? It will gain a negative charge. So it becomes a negative ion. So you will see that after the transfer of electrons, both the atoms will acquire the electronic configuration of the nearest inert gas, that is 8 electrons in its outermost orbit. Okay, so the metallic element, as I already explained, which loses electrons, it becomes a positively charged ion and which is known as cation. And a non-metallic atom which gains electrons, I already explained to you, becomes a negatively charged ion which is known as an anion. So positively charged ion is known as cation and negatively charged ion is known as an anion. So to define an ion is a charged particle which is formed due to the gain or loss of one or more electrons by an atom. Okay, so a metallic element whose one atom readily loses electrons to form a positively charged ion is an electropositive element. So you see that sodium is a metal. It can lose 1 electron and it will become positively charged. Okay, so similarly a non-metallic element whose atom will accept electrons to form a negatively charged ion is known as electronegative element. So chlorine is a non-metal. It can gain electrons to turn into an anion. An anion means a negatively charged atom. Now, the cation, you know, it is positively charged, and the anion, you know, is negatively charged. So, they are oppositely charged. So, they attract each other and they form a chemical bond. Okay. So, since this chemical bond formation is due to electrostatic force of attraction, because, you know, the positive and the negative, they will attract. So what happens? There is an attraction between a cation and an anion, and the bond is so strong that it is not easy to separate them. So that is how sodium chloride, that is the common salt, is formed. Because sodium is positively charged, chlorine is negatively charged, and there is a strong bond between them. So that bond is known as electrovalent or ionic bond. Okay. Now, electrovalent or ionic bonds is defined as the chemical bonds formed as a result of the transfer of electrons from one atom of an element to one atom of another element, and that bond is known as ionic bond. And to define an electrovalent compound, you'll define it as the compound formed by transfer of electrons. Okay, and electrovalency means the number of electrons that an atom of an element loses or gains, either how many electrons are given or it is received. To form an electrovalent bond is known as electrovalency. So metals, I already told you, have 1, 2 or 3 electrons in their outermost or valence shell. So they have a tendency to lose their valence electrons. Remember, all metals form positive ions. So they combine always with non-metals, because non-metals have 5, 6 or 7 electrons in their outermost shell. So they have a tendency to gain electrons, and in the process they form ionic bonds. So remember, children, bonds that are formed between metals and non-metals are ionic or electrovalent bonds. Now, ionic compounds are stable. Why? Because they give away electrons. One atom will give away electrons and the other atom will receive electrons. So what happens is, one atom becomes positively charged and the other atom becomes negatively charged. Okay, so they will pull each other. But not only that, there is also a repulsive force. Repulsive force means a force which tends to push away ions, because there are like charges also, positive charges in the nucleus, the protons. Negative charges are also there. Okay, but the electrostatic force of attraction between opposite charges is higher, that is the positive and negative. So the ionic compounds are stable. Now these are the examples of ionic compounds formed between a metal, sodium chloride, that is a non-metal. Okay, now cesium fluoride is the most ionic compound, as cesium has the maximum tendency to lose an electron, while fluorine has the maximum tendency to gain an electron. So please remember, children, that cesium fluoride is the most most ionic compound. Okay, now the features that is common to all ionic bonding: metal atoms always lose their outer electrons to form positive ions. Non-metals, with one exception of hydrogen. Hydrogen is the only non-metal which has a positive charge, because hydrogen has only one electron in its outermost orbit, so it can easily lose electrons. Okay, and becomes positively charged. So in both the cases, the ions formed have a stable electron arrangement, that is, they have more or less an octet configuration. And ionic bonds results from attraction between opposite charged ions, that is a positive and negative. Now your assignment will be to draw the structures of some electrovalent compounds. So first we will talk about how sodium chloride is formed. So look at this diagram. The electronic configuration of sodium is 281. Chlorine is 287. So sodium will give its 1 electron in its outermost orbit to chlorine, which has 7 electrons. So now sodium will lose, how many orbits were there? 3 orbits were there. So it has, since it has given away, now how many will remain? 2 will remain. So what is the electronic configuration of the sodium ion? 2 and 8. Since it is giving away 1 electron, a positive charge is formed, and then your chlorine will receive that electron which is given by sodium, and the outermost orbit, now it was 7, now it becomes 8. Okay, so that is the chloride ion. So between positive and negative, there are Coulomb forces between them, and they will attract together to form the compound which is known as sodium chloride. Okay. Now next we will talk about the formation of magnesium chloride. Okay, take a look at this diagram now. Now magnesium, the diagram, see, magnesium chloride is MgCl2. That means how many chlorine atoms must you take? You have to take 2 chlorine atoms. So magnesium, this is the electronic configuration of magnesium, 282, and chlorine 287. Now there are 2. So the 2 electrons in the outermost orbit of magnesium is given to each chlorine 1 here and another 1 here. So what happens? Magnesium 2 and 8 and chlorine 288. So what is formed? Magnesium chloride is formed. Okay, and this is known as the electron dot structure of magnesium chloride. That is, you just write the formula and write down how many, with a dot, how many electrons are there in the outermost orbit. So magnesium has 2, and you'll have to show chlorine 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and by means of an arrow you have to show that 1 electron has been given to form magnesium chloride. Okay, so similarly, moving on to the orbit structure. This is the orbit structure. Okay, now calcium 2882, that is the electronic configuration. It has 4 orbits and 2882. So that 2 must be lost to oxygen. The electronic configuration of oxygen is 2 and 6. It has 2 orbits, and the first one has 2 electrons and the second orbit has 6 electrons. So the 2 electrons of calcium is given to oxygen. So 6 plus 2 becomes 8, and after losing the 1 orbit, because the 2 electrons which was there in the valence orbit is given away. So the electronic configuration of calcium becomes 288. So they are both stable, and then one becomes positively charged, the other becomes negatively charged. Since it has given away 2 electrons, it is 2 plus, it has received 2 electrons, it becomes 2 minus. Okay, and this is your electron dot structure of calcium chloride. Children, please draw both the diagrams, the orbit structure as well as the electron dot structure. Okay, so here you will show by means of calcium. I already explained 1 electron going to oxygen and how calcium oxide is formed. Okay, so remember children, electrovalent compounds, they have strong electrostatic forces of attraction between their ions, and it is not easy to separate them. Otherwise, you know, sodium is a poisonous metal, chlorine is a poisonous gas, but when they come together to form sodium chloride, you cannot live without it. Your food will not be tasty without it. So they form completely new compound, and it cannot be separated easily. So they are hard, brittle crystalline solid which is made up of ions. Okay, they are non-volatile, that means they do not evaporate easily. They have high boiling and high melting points. They do not conduct electricity in the solid state, but when they are melted, that is fused, or aqueous means when they are dissolved in water, then they can conduct electricity. Okay, so in the next upload we are going to talk about covalent bond. Covalent bond means sharing of electrons. Okay, so till then children, stay safe. God bless you.